So far, we have learned 5 different exponent rules, and we still have 2 more to learn, but at this point we're going to take a step back and practice kind of a mixture of them where you might see more than one rule in the same problem. So let's start with these examples. We have 3 to the negative 2 times 3 to the positive 2. So this is an example of the product of a power property. One that looks like a to the m times a to the n equals a to the m plus n. So that means we're going to keep the same base and we're going to add the exponents. Negative 2 plus 2 is 0. And then that looks like an example of the zero power property, where we know that anything raised to the 0 power equals 1, just as long as the base is not 0, and then that one's undefined. So 3 is not 0, which means this is 1. Final answer is 1. For our next example, we've got 2 raised to the negative 3 raised to the negative 2. That is an example of our power of a power property. That's the one that looked like a to the m to the n, and we kept the same base and we multiplied the exponents. So for this one, we'll keep the base of 2, and then we'll do negative 3 times negative 2, which is positive 6. Now again, you can leave your answer like that, or if you wanted to, you could do 2 to the 6th in your calculator and you would get 64. Either of these are equally correct. Next, we've got 3 raised to the negative 4th power. That is our negative exponent rule. Remember, that was kind of almost a 2-in-1 rule, where basically wherever the negative exponent is, whether it's top or bottom of a fraction, you're going to move it. So if you had something like a to the negative m, it became 1 over a to the positive m. Or if you had something where the negative exponent was in the bottom, it would move to the top of the fraction. So for this one, we're going to move the 3 to the 4th to the bottom of the fraction, and it will become positive. You can leave your answer like that if you like, or you can simplify 3 to the 4th, which is 81. Both of those are equally correct. Let's do 2 more examples here. We've got 5a raised to the negative 2 power. Now that starts off as our negative exponent rule again, where we would have 1 over 5a to the positive 2. And then 5a quantity squared is an example of our power of a product rule. That was the one that looked like a times b to the m. And we said, although it's not technically distributing, it should remind you of distributing. The factors inside of the parenthesis all get that exponent. So for this question, in the denominator, the 5 and the a both get squared. So this becomes 5 squared times a squared. Again, you could leave it like that if you like, but 5 squared is pretty easy to do even in your head without a calculator. 5 squared is 25. So then we end up with 1 over 25a squared. All right, and we've got one more here. We've got a negative exponent in the denominator. D raised to the negative 3 is in the denominator, which means it moves to the top of the fraction and looks like that.